Okay, so we had just finished looking at two examples called the product of the sum and difference of two terms. So let's go back and look at one of them. Notice how everything is almost exactly the same. 4x and a 5, 4x and a 5. The only difference is that one is a sum and one is a difference. Or if you look up here, same thing. One is a sum and one is a difference. So you'll notice in both of those examples, the two middle terms added up to 0, which means our final answers only had two terms. So our final answers were binomials. That middle x term is no longer part of our answer because of the nature of the sum and the difference. You get one negative and one positive, and they add up to 0. So let's look at kind of like a formula for this. So if we have an a plus b and an a minus b, we do FOIL. That's going to give me a squared. My outside is going to give me minus ab. My inside is going to give me plus ab. And my last two is going to give me minus b squared. Okay? Now let's look at a couple things here. First of all, when I do the inside, it might look like b times a, and you might want to write ba, but that's the same as a times b, ab. Multiplication is commutative, so I could write it as ab or ba. And right here, make sure you realize that that is a minus, because you're doing a positive b times a negative b. So b times b is b squared, but when you do one positive times one negative, it's negative b squared. Alright, now you'll notice these two middle terms are the same except for their sign. They're opposites of each other, so they will add up to 0. So our final answer will just be a binomial, a squared minus b squared. So anytime you have a problem where you notice you have the sum and difference of two terms, like we have here, this is a sum, this is a difference, but everything else is the same, 3x4, 3x4. Think of this as your a and this as your b. And then just realize that the middle terms will add up to 0. Excuse me. So all we have is a squared. So our a is 3x. So a squared minus b squared, which is going to be minus 4 squared. So our answer here is going to be 9x squared minus 16. Now, of course, if you're still more comfortable doing FOIL and writing out all four terms, of course you can do that. It's just that eventually this will be a time saver for you if you notice the pattern. Alright, let's look at another pattern here. We have something called the square of a binomial sum. So it says find the product using the FOIL method. Alright, now basically what we have here is a binomial being squared. Okay, let's just recall first what it means for something to be squared. So this is kind of a side note example. If I said do 3 squared, it means you're doing 3 times 3, which would give me 9. So let's look at this. If I'm doing this binomial squared, it means I'm taking the binomial x plus 10 and I'm multiplying it by itself. So this then becomes a FOIL problem. X times x for my first two is x squared. My outside gives me 10x. So does my inside. And my last two gives me 10 times 10, which is 100. Now notice in the middle when we go to combine like terms, our terms don't cancel out anymore because they're both pluses, but now we have two of them. We have 10x and another 10x. So we have 20x. So this becomes x squared plus 20x plus 100. Now I want to show you what a common mistake is that we see very often in a problem like this. And I want to make sure you don't do this. A lot of times what students do is they say, oh, okay, let's square x, let's square 100, and let's call it a day. And they think the answer is x squared plus 100. Absolutely not. Do not do that. Okay? This is your warning. You don't want to do that. As you can see here, clearly we have two terms in the middle that add up to 20x. Alright, let's try another one. Let's try number 2. Same thing, we have 2x plus 3 quantity squared. What that means is you're taking the whole quantity and squaring it. So that means you have 2x plus 3 times itself. Alright, first, 2x times 2x is 4x squared. Outside, there's a plus 6x. Inside, there's another plus 6x. And my last two, 3 times 3 gives me a plus 9. So then we combine like terms in the middle here. And I get a final answer of 4x squared plus 12x plus 9. Alright, let's look at the pattern for this one. So if I'm doing a plus b quantity squared, I'm doing a plus b times a plus b. So when I do FOIL, I'm going to get a squared. And my outside, I'm going to get ab. My inside, I'm also going to get ab. Remember, you don't want to write it ba, you want to write it ab, so you notice they are like terms. And my last two, now I'm going to get plus, because they're both positive, b squared. So now, when I combine like terms in the middle, they don't cancel out, I get two of them. So I get a squared plus 2ab plus b squared. So now, when I have a binomial being squared, think of this as a, think of that as b. So let's look at my formula. This tells me I'm doing a squared, so 5x quantity squared, plus 2 times a times b, and then plus my b value being squared. So this gives me 25x squared plus 40x plus 16. And again, if you're not comfortable using the formula just yet, if you'd rather write it out and do FOIL and combine like terms in the middle, that's absolutely fine. If you would have done FOIL on this one, you would have got 25x squared plus 20x plus 20x plus 16. And your 20x's in the middle would be your 40x right there. So it's up to you. Until you feel comfortable using the formula, you can do FOIL. Alright, let's look at one more pattern. It's called the square of a binomial difference, which is basically the same as what we just did, except now you'll see a subtraction sign instead of a plus sign. But the same rules apply. If we're squaring it, that means we're multiplying it by itself. So this is going to give me x squared for my first, minus 9x, and then another minus 9x, and then the last two. Now notice, this is a negative 9 times a negative 9, so this becomes plus 81. Now when I combine like terms in the middle, I get negative 9x minus 9x again, so that's minus 18x, and I end with the plus 81. So notice that both of these end with a plus. Over here, we ended with a plus 100 because we were squaring plus 10 times plus 10, which becomes plus 100. Over here, we ended with a plus 81. Even though we had a minus 9 and a minus 9, when you do negative 9 times negative 9, it becomes positive 81. And notice how that's different. Let's go back a little bit. Notice how these all ended in minus, because when you squared at the end, you were doing a positive 4 times a negative 4. So you're still doing 4 times 4, which is 16, but it's a positive times a negative, so that's why these all ended up with a negative. Do another example. 2x minus 5 times 2x minus 5. First is 4x squared. My outside is minus 10x, so is my inside is minus 10x. And my last two, that's a negative 5 times a negative 5, that becomes a plus 25. And when I here. It says a minus b times itself. So this is going to be a squared minus ab minus another ab, and then I'm going to get plus b squared. So when I combine in the middle, I have two of these. I have two negative ab's, so minus 2ab. So a squared minus 2ab plus b squared. Alright, so now let's see if we want to use the pattern here. 3x is my a, 7 is my b, and just think of b as 7. Don't think of it as negative 7 at this point, because the formula already has the minus built in for you. So this says we do a squared minus 2ab plus b squared. So a is 3x, and then minus 2 times a, so 2 times 3x times 7, and then plus 7 squared. Alright, so 3x quantity squared, that's going to give me 9x squared, minus 2 times 3 times 7, that's 42, and then x, and then plus 49. So that gives me 9x squared minus 42x plus 49.